This example says, find the volume of tetrahedron. Tetrahedron bounded by planes. Okay. The planes that we have are x plus 2y plus z equals to 2, x equals to 2y, x equal to 0, and z equal to 0. Very good. So the very first thing that you should be asking is, well, what is the base? In x and y, what do we have? If you try to graph this in 3D, three-dimensional, the graph that you're going to get is going to be very similar to the situation that we have here. X, Y, and here we have Z. So I should change that. So you're going to get a 3D object like this. Just connect these to my best skill of graphing. Okay. Then we have this plane just right here. So this guy is your x plus 2y plus z equals to 2. Then here you have on this side, I don't want to shade too much. It's equal to x equals to 2y, or y equals to x divided by 2. Very good. So this is the object that you have, all right, 3D object. The very important question is, well, what is the base? I have the ceiling. I don't have any issue with the ceiling. What is this base down here? Very good. To find the base, remember that in xy plane, there is no z. So all of these z values are equal to 0. To graph the base, z is equal to 0. So it means that you have x plus 2y equals to 2. Then you have x equals to 2y. Then you know that x is equal to 0. So you can easily graph this in xy plane. In x and y plane, you have the following scenario. So here you have, let's just graph these two lines. Here you have x equals to, well, 2 minus x. You're going to divide both by 2. 1 minus x divided by 2. And you have y equals to x over 2. Well, this is y equals to x over 2. And you have a decreasing line which passes through 1. And it's going to just right here. So this is your y equals to 1 minus x over 2. So this is your base. This object in xy plane is represented this way. So down below you have y equals to x over 2, and up y is 1 minus x over 2. Right. So let's try to find a volume. Volume is equal to the double integral, right? Well, what is the ceiling? The ceiling needs to be written in terms of z equals to x and y. So my z is equal to 2 minus x minus 2y. This is my ceiling. 2 minus x minus 2y, and then dA. Now we're going to decide which one is going to be the outer integral and which one is going to be the inner integral. So obviously, if you set these two equal to each other, you can find the intersection. X divided by 2 is equal to 1 minus x divided by 2, or x over 2 plus x over 2 is 1, or here you have x equals to 1. My x is bounded between 0 and 1. All right. This is the boundary for my x. and the y is bounded between x over 2 and 1 minus x over 2. So let's try to calculate the volume using x as the outer integral. And for the inner integral, you have your y, which is bounded between x over 2 and 1 minus x over 2. So let's do the computation. This guy becomes integral 0 to 1. Here we have to take the integral with respect to y. So you get 2y minus xy minus y squared. Y is bounded between x over 2 and 1 minus x over 2, then dx. So let us plug in 1 minus x over 2 and then x over 2, do the computation. This guy becomes integral 0 to 1. Here you have 2 times 1 minus x over 2 minus x times 1 minus x over 2 minus 1 minus x over 2 to the second power minus, now we're going to enter x over 2. Here you have 2 times x over 2 minus x times x over 2 minus x over 2 to the second power dx. Okay, let's try to simplify this as much as we can. Here you have 2 minus x plus x squared over 2. And here, if you just write this guy and then distribute the negative 1. And here you have plus x. And here you get negative x squared over 4 minus, and then for this guy can cancel out 2 and 2, you get x, and you have plus x squared over 2 and plus x squared over 4 dx. So you have some opposite terms that you can get rid of. For example, here you have negative x squared over 4 and x squared over 4. This guy becomes integral 0 to 1, and 2 minus 1, it gives you 1, negative 2x minus 3x, and then here you have x squared over 2 plus x squared over 2, which is just x squared dx. So let's take the integral with respect to x, which becomes x minus 3/2 x squared plus x cubed divided by 3, 0 to 1. Very good. Let's see if we didn't make any mistakes here. Make sure all the computations are correct, so we can move forward. So here we have 2 minus x plus x squared over 2. I just want to let me do the algebra here. We have minus 1, and here you have minus x plus x squared over 4, which becomes negative 1 plus x minus x squared over 4, and then here you have minus x plus x squared over 2, and you have a plus x squared over 4. Okay. So we have 2 minus 1, which is 1, negative x minus x, which is negative 2x, and here we have, it should be plus, am I right? Yes, here we have negative, and oh yeah, here we have this guy, it should be plus, am I right? Okay, so you have a plus that I forgot to add, so that's how we get negative 2x. Very good. So that's how we got just minus x squared. Now it's much more accurate. Okay, I forgot to add this one. So here you have 1 minus 1 plus a third, which is 1 over 3. This is the volume of this tetrahedron.